So in this video, we're going to start to learn the variable selection procedure. Although in your textbook, you will notice that they are teaching you 3 different methods: backward elimination, forward selection, and stepwise regression. In this class, in this semester, we only learn one method called backward elimination. The reason is because if you only have Excel, you only can perform backward elimination. If you want to do forward selection or stepwise regression, there is a lot of calculation. It will be a calculation intensive procedure and won't be efficient. So therefore, we only focus on the backward elimination. So when we look at the backward elimination, our forward selection or stepwise regression, I want to import a very important term called iteration. So all 3 procedures involving iteration. Basically, you're repeating the same step again until you find the best result. So here I mentioned in this slide is one independent variable at a time is added or deleted based on the p-value. So if we work on the backward elimination, means one independent variable at a time is deleted based on p-value. So how we perform it? Let's look at our flowchart of this iteration. So we call backward elimination is always starting from all x variables. So for instance, if your project has 5 x variables, if you want to do the backward elimination for your project, because there is one section required to do the backward elimination. So one thing I want to mention is for that section, backward elimination, you only need to let me know what is your best model. You don't need to do the interpretation again. You don't need to do the diagnostic again. You don't need to do the prediction again. The only thing you need to do in that section is just let me know what is your best model. And so before that step, make sure you are doing the like prediction, your R-square, your significant test based on your model that including all the variables. So in the backward elimination, you're starting all the predictors. So if you have 5 predictor in your data set, so when you run the regression in the first step, you're including all 5 variables, So after you got your result, you need to pay attention on, do you have any predictors p-value? So you look at the t-test for each individual x variables in that outcome. So look at the p-value. So how many of the you just need to look at the largest p-value for your predictors, exclude the b0. So the b0 is non-important because the b0 is your y-intercept. You look at your b1, b2, b3, etc. So look at which b's p-value is the largest one. So then you find the largest one, and then look at that largest p-value, whether it's larger than 0.05. If that's the case, and then you go back to your original data set to delete that corresponding predictor. You only delete one at one time. So you only find the one give you the largest p-value, and then you go back to delete it. And then you rerun the regression with the remaining predictors. So if you're starting from 5, so after you delete one predictor, and then you're going to rerun the regression model using the rest of 4 predictors. And then after you get a result, to look at which b except b0 give you the largest p-value. And then if the larger p-value is still larger than 0.05, and then you go back to your original data set and delete it. So then the question is when you should stop deleting. So after you run the regression model, if all the p-values more than 0.05, so that's the moment you should stop. And then that means that is your best model. So that is your best model. So after I explain the rationale behind it, let's look at an example. So make sure after you look at the example, you're going to go to look at a computer skill 6, because on that computer skill 6 example, I will teach you on how to use Excel to perform the whole steps. Here, this example only showing you the idea, but in computer skill 6, I actually going to show you how to use Excel to perform the backward elimination. So for this example, we look at what's going to affect the housing price. And so here, the people collect 25 houses at the Clarks Valley. And so they are thinking the potential factor affecting housing price, including the house size, the number of the bedroom, the number of the bathroom, and the garage size. So here are looking at the 4 factors. So the y variable will be the house price, x1, home size, x2, number of the bedroom, x3, number of the bathroom, x4 is the number of the car can fit in the garage. So now they have 4 predictors. So now let's do the backward elimination. So for the backward elimination, starting all predictor in one variable. Therefore, we run a regression model with x1, x2, x3, x4. So this is our result. So this result is partially result. It's coming from the third table from your regression outcomes. So therefore, this is my B0, B1, B2, B3, and B4 information. So this is the value for them, right? B1, B2, B3, B4. So now we're going to focus on our p-value. So although you see we have many predictors, p-value is larger than 0.05, we only focus the larger the p-value. So the larger p-value exclude p0, b0 is this one, right? 0.69680, so that is corresponding to cars. So this is the largest one and the larger than 0.05. That means cars has the most insignificant relationship to affect the housing price. Therefore, what we're gonna do is we're gonna go back to my original data set. We're gonna remove that column called the cars and then rerun the regression model with the rest of the predictor x1, x2, x3. And then this is our result with only the rest of 3 predictors. So we pay attention to the p-value. We don't need to worry about the p-value for b0. It never need to, because that's not telling us the relationship how x related to y related to x. Instead, we pay attention on the rest of 3. So now look at the p-value. Which p-value is the largest one? Yes, 0.28. So that p-value is corresponding to the bedroom. So that's what we're going to do is we go back to our original data set. We're going to delete bedroom, that variable, and rerun the regression model with the rest of 2. So this is our result. So now we notice that the highest p-value is this one, still larger than 0.05, right? That's corresponding to the bathroom. Therefore, we go back to our original data set. We're going to delete the bedroom and rerun the regression model. So then we got this output. So obviously, the smallest the p-value, the only predictor we have is house size, and the p-value equal to 8.7e negative 0.9. So this is the Excel scientific notation. That means 8.7 times 10 powered by negative 9. So therefore, if you want to keep 4 decimal places, this actually is a very small value equal to 0.0000. So it's very, very small. Therefore, you have nothing to delete except you write down your best model. It is y hat, which is your housing price, equal to negative 9.8669 plus 11.3383 times the x1, which is your house size. So this is your best model.